The atmosphere is an envelope of gases and air that surrounds Earth. The weight of all the air around the Earth acts as a small force that puts pressure on organisms and particles. This is called atmospheric pressure. As the height of an object increases, or the altitude, the atmospheric pressure decreases. This means that at sea level, the atmospheric pressure would be higher in contrast to the atmospheric pressure in space. When the altitude of a particular object is high in the sky, there is less gravity in comparison to objects that are located on the ground. This is because objects on the ground are closer to the Earth's core, which is where gravity is the strongest. As there is less gravity in the sky, air particles are able to expand and rise. As a result, the molecules in the air are able to spread out more. Elements and compounds such as nitrogen, oxygen, and carbon dioxide are unable to disperse, making it less likely for them to bump into each other. Due to all of these air particles being spread out, the air density decreases and aeroplanes are able to move faster with more efficiency. Most aircrafts, including jet aeroplanes, use a combustion engine in order to achieve the necessary power to take off and stay in the air. These engines require a certain amount of oxygen to be able to work. This is the reason for powered aircrafts having to remain at an altitude with ideal atmospheric environmental conditions. The surrounding of the aircrafts must have low turbulence, more safety, and a sufficient oxygen supply. The minimum altitude for these conditions is around the ballpark mark of 10,000 meters. Other benefits of aeroplanes cruising above 10,000 meters include the fact that they are able to avoid other planes, reduce the risk of crashing into mountains, and prevent the risk of colliding into birds. The troposphere is relatively warmer towards the bottom and colder towards the top. In contrast, the stratosphere is colder towards the bottom and hotter towards the top. This temperature difference between these two layers of the atmosphere is due to the UV light passing through the ozone layer, triggering exothermic reactions. Ozone molecules in the stratosphere absorb ultraviolet rays from the sun, converting the UV energy into heat. Unlike the troposphere, the higher you go in the stratosphere, the warmer it gets. This is because an object's altitude increases the closer it gets to the sun.